Off the Caribbean coast of Panama lies the San Blas Archipelago, a chain of isolated islands inhabited by the Kuna Indians. The Kuna diet contains a striking biochemical anomaly. They consume massive daily quantities of a traditional, unrefined cocoa beverage. On average, an island-dwelling Kuna ingests roughly 1,880 milligrams of procyanidins every day. Procyanidins are a class of oligomeric flavonoids that occur naturally in plants and act as powerful signaling molecules in the human body. Clinically, this population exhibits a near-zero prevalence of age-related hypertension. Their rates of myocardial infarction and stroke are a fraction of what is observed in typical Western populations. This chart compares the blood pressure trends of the island-dwelling Kuna with those who have migrated to mainland Panama. The islanders maintain a flat, low blood pressure line throughout their lifespans, while the mainland Kuna show a steeply rising trend line typical of modern industrialized populations. The stark difference eliminates genetics as the primary variable. The islanders are undergoing a continuous, high-dose pharmacological intervention through their unrefined cacao intake. Translating this intervention to the modern consumer presents an immediate problem. In the industrialized world, cacao is almost entirely consumed as processed chocolate. To match the 1,880 milligrams of procyanidins consumed by the Kuna using commercial chocolate, a person must ingest a massive caloric load, along with high concentrations of stearic acid and sugar. Recent testing exposes an even more severe toxicological artifact. Consuming commercial dark chocolate in quantities large enough to hit clinical thresholds exposes the consumer to dangerous levels of heavy metals like lead and cadmium. To find a safe therapeutic window, we must separate the underlying pharmacology of the cocoa plant from the industrial mechanics of chocolate production. The perception of dark chocolate as a health food is flawed. It conflates the biochemical brilliance of the raw plant with a highly compromised industrial delivery mechanism. The term superfood obscures the actual mechanisms at work. The active medical agents in raw cacao are flavin-threols, specifically a molecule called epicatechin. Flavin-threols are a specific derivative of flavonoids that accumulate in high concentrations in the seeds of the cacao tree. This is the molecular bedrock of epicatechin. It features a tricyclic C15 flavonoid skeleton built from two benzopyrin rings, A and C, and a benzene ring, B. This geometry allows the delocalization of electrons across the aromatic system, creating a highly stable structure. The electron delocalization powers a process called phenolic quinoid tautomerism, which enables the molecule to aggressively neutralize reactive oxygen species. Reactive oxygen species are highly unstable molecules containing oxygen that easily react with other molecules in a cell, causing significant tissue damage. Epicatechin executes this function with extreme efficiency. It quenches hydroxyl radicals 100 times more effectively than mannitol, the standard pharmacological scavenger. Direct radical scavenging is only the first line of defense. The primary cardiovascular power of epicatechin comes from its ability to act as a targeted enzymatic signaling molecule. Atherosclerosis begins with endothelial dysfunction, a condition largely driven by superoxide production from an enzyme called NADPH oxidase. NADPH oxidase is a membrane-bound enzyme complex that generates superoxide radicals as a primary function, which can aggressively degrade the vascular wall. Epicatechin acts as a direct inhibitor of NADPH oxidase. It effectively shuts down the localized production of vascular oxidative stress at the source. This chart outlines epicatechin's secondary, crucial signaling function. It acutely upregulates endothelial nitric oxide synthase, or eNOS, within the vascular endothelium. Inside the cell, eNOS converts L-arginine to L-citrulline. The byproduct of this precise conversion is the release of nitric oxide gas. The nitric oxide molecule travels to the smooth muscle and activates soluble guanylate cyclase, driving up levels of cyclic guanosine monophosphate, or cGMP. The rise in cGMP inhibits calcium flux, dropping the cytosolic calcium concentration. This chemical shift forces the physical relaxation of the smooth muscle. Epicatechin's ability to induce systemic vasodilation is entirely dependent on this nitric oxide pathway remaining intact. Endothelial health is measured clinically using flow-mediated dilation, or FMD. FMD is a non-invasive ultrasound technique that measures how well an artery dilates in response to increased blood flow, serving as a highly accurate predictor of future cardiovascular events. In 2008, a clinical trial tested high flavanol cocoa on a highly compromised population, medicated diabetics. To achieve clinical relevance, the researchers utilized a specific dosing protocol. Patients consumed over 900 milligrams of total flavanols daily, strictly split into 3 intervals. This chart shows the acute results of the trial. Notice the massive FMD spikes, peaking exactly 2 hours post-ingestion. This timing mirrors the pharmacokinetic half-life of epicatechin in the bloodstream. Look at the sustained results, marked by the squares, over the 30-day axis. The baseline FMD of the patients significantly augmented compared to the flat control group, proving chronic vascular adaptation. Reaching these levels of chronic vascular improvement requires a massive daily intake of flavanols, a dose that commercial chocolate is actively engineered to prevent you from getting safely. Raw cacao pods are naturally rich in these polyphenols, but the chemical compounds themselves are highly astringent and bitterly unpleasant to the modern palate. Commercial chocolate processing aggressively ferments, roasts, and alkalizes the cacao specifically to destroy these bitter flavanols. This alkalization is known as Dutching. Dutching is a chemical process that washes cocoa with a potassium carbonate solution to neutralize acidity and darken its color, stripping away the active compounds. Attempting to eat enough high-percentage dark chocolate to overcome this induced flavanol deficit exposes the consumer to cadmium and lead. Cadmium in chocolate is largely a bioaccumulated soil artifact. Its presence depends heavily on the volcanic or agricultural history of the specific farm, particularly in Central and South America. Lead contamination occurs through a different pathway. Unlike cadmium, lead is almost entirely a post-harvest industrial refinement artifact. The pursuit of a cardiovascular cure via commercial dark chocolate products often results in slow, accumulative toxicological poisoning. The primary culprits of lead contamination in the supply chain are bearing-based ball mills and large-scale universal grinders. A ball mill is an industrial cylinder filled with steel balls used to grind materials into extremely fine powders through impact and attrition. These machines rely on extreme pressure, dragging metal blades against a metal drum to grind the cacao into a micro-smooth paste. The longer the cacao stays in the universal grinder to achieve a premium, smooth mouthfeel, the more microscopic metal particulates are sheared off and suspended permanently in the fat of the chocolate. Industrial smoothness correlates directly with heavy metal toxicity. The mechanical process used to make the chocolate palatable is exactly what contaminates it. Traditional pre-industrial methods like stone grinders or roll refiners achieve particle reduction with zero metal-on-metal contact. To utilize epicatechin as a viable medical intervention, the practitioner must bypass commercial chocolate bars entirely. This chart summarizes the required protocol. Achieving the target mechanism of eNOS upregulation requires optimal delivery vehicles, unalkalized, low-fat cocoa powders, or stone-ground artisanal cacao sourced from low-cadmium regions like West Africa. You must avoid Dutching and ball mill refinement. Cocoa is a highly potent, dose-dependent vasodilator. By understanding the molecular biology of the plant and the mechanical realities of the factory, we can isolate the cure from the poison.